Hello students. So our next topic in the chapter heat is convection of heat. Convection is the mode of heat transfer by the movement of particles. In the last class we have read about conduction of heat in the solid particles, whereas convection is the primary mode of heat transfer in fluid, that is liquids and gases. It is because molecules of fluids are loosely arranged with space between them, which allow their movement. In your text, there is an activity with a round bottom flask and water to show that liquid transfer heat by convection. By this activity, we can explain the convection current in water. To show that liquids transfer heat by convection, we need the materials like a round bottom flask, some cold water, and a chemical called potassium permanganate. First of all, gently place a small crystal of potassium permanganate, which is a chemical available in the chemical laboratory in our school. We have to put it into a round bottom flask. You can see in the setup, this is the round bottom flask, which is a glassware available in lab, which is kept on a tripod stand, and there is the Bunsen burner for heating the water, and this flask is set up with the help of a stand and clamp. So we will place the crystal of potassium permanganate, which is a colored crystal, in the water of the flask. Then we will heat the water near the crystal with a Bunsen burner. After a few time, you can observe the movement of the purple colored crystals of potassium permanganate. How? The purple colored solution will start showing a circular movement in the liquid. First it rises from the place of heating, moves a bit away, then again moves down back to the bottom of the flask. Bottom of the flask. We can do this activity with another setup also. Let's see what is it. Instead of round bottom flask, we can use a beaker as well. Here you can see, instead of round bottom flask, we have taken a glass beaker with cold water and the potassium permanganate crystal. As soon the water gets heated up, the colored crystal show movement in this way. So from this activity we can conclude that in liquids, heat is carried from one part to another by the actual movement of hot particles, that is by convection. So this movement of hot particles in the liquid is known as convection current. Now the point is, why does water in the flask move in this fashion? Water near the bottom of the flask gets heated first. Now as we know, warm water is lighter in weight than the surrounding cold water. So the warm water rises up and the colder water from the surrounding moves down, again gets heated up and rises up. This process continues until the entire water attains a uniform temperature. Because of this cyclic movement of water, we can see the convection current in liquid. In this figure, you can see how the water molecules show the cyclic movement, which is clear due to the presence of purple colored potassium permanganate crystal. Not only in laboratory, we can see in our daily life at home as well. While you are boiling some water in a transparent container, you can easily see the cyclic movement of water molecules in this pattern. This is known as convection current, which is responsible for the movement of air from land part to the sea and vice versa. So convection current in air is responsible for land bridge and sea bridge. Also, we experience storm or heavy wind, cyclone, and the similar environmental factors due to this convection current. So now we can define convection in the following way. Heat transfer in which heat is carried from hotter part of a substance to its colder part by the actual movement of the hot particles is called convection. So only liquids and gases transfer heat by convection. Solids cannot transfer heat by this process because in solids the constituent particles cannot leave their place. But in liquids and gases, particles have much intermolecular space, so they can move from their place. As soon they absorb heat, they start moving away from each other. Now we will learn about the applications of convection in our life. We will first start with land bridge and sea bridge. So, land bridge and sea bridge is an example of convection current in gases. When the sun heats up the land during daytime, the land gets heated up faster than water in the sea. Therefore, during daytime, the air above the land gets warm and rises up because hot air rises up, and the air from over the sea, which is cooler comparatively, flows in to occupy the empty space in the land. This result in sea bridge, which we call the bridge we call as sea bridge, because the hot air being lighter in weight rises up. Therefore, the cool air from sea rushes to the empty space. This forms the cyclic movement of the gas. At night, just opposite happens. The land cools down much faster than water in the sea. Hence, the air above the sea is now hotter than the land air. Therefore, this air above the sea being lighter in weight rises up, and the cool air from land rushes in to take its place, which form the land bridge. So students, please pay attention on this event. And I must say this part is very important of this chapter. You have to draw the figure. Those who already have collected your textbook, you can draw from your textbook as well, because This diagram is not exactly from your textbook, it is from another textbook, but you can draw this one also. These two diagrams, please draw and color and label properly, which shows formation of land bridge and sea bridge due to ununiform heating of land and water, which is causing convection current. So this concept of land and sea bridge is actually applicable on ocean currents. Ocean water near the equator gets heated by the sun rays because the equatorial region of Earth gets the most amount of heat from sun. As a result, the ocean water in the equatorial region become hotter and lighter. The ocean water in the polar region is colder in comparison, therefore denser. So due to this temperature difference, warm water starts flowing on the surface of ocean from equatorial region to the polar region, and the cold water starts flowing from the polar region to the equatorial region below the surface of the ocean. Such flow of ocean water forms ocean current. You know, this ocean current help in maintaining the temperature in the oceans. Now let's see in our daily life what are the factors that depend on this convection current, like ventilation in rooms. Warm air being lighter rises up and leaves the room through ventilators. Therefore, ventilators provided they are placed near the ceiling. On the other hand, fresh air from outside enters the room through the doors and windows. Convection current, so set in the air, helps in keeping the room fresh. Therefore, while placing ventilators, doors and windows, these factors must be remembered. So some interesting factors regarding this, like number 1, why are room heaters placed at or near the floor of the room? That is, why not near the ceiling? It is because air heated by the room heater goes up and the cooler air from the height or higher level comes down. This cooler air again gets heated up and go up again. Thus it forms the convection current of warm air and cooler air, and the room gets warmer faster. Again, one more question, that is, why is the freezer mostly located at the top in the refrigerator? It is because the air inside and around the freezer compartment gets cool and moves downward, and the lesser cool air inside refrigerator moves up to get cooled again. Thus, the convection current is set in the air, and lower section of the refrigerator also get cooled faster. The same way, cooler is placed at a height in a room. Okay, so at the end of this topic, let's try to answer these questions. Question number 1, which form of matter does not transfer heat by convection? Yes, you know the answer. It is solid. Question number 2, name the mode of heat transfer in which particles actually move to the surrounding. Number 3, during ventilation, what is the direction of the convection current? And number 4, what is the flow of cooler air from the land towards the sea called? So please try to answer these questions. Read the lesson properly. Thank you. See you in the next class.